In classical object-oriented programming, we often use design patterns. Many of them are described in the Gang of Four book. All these were established before C++ had proper support for functional programming. std function, as an example, is only in the standard since 2011. Now we can make a lot of these inheritance-heavy patterns simply vanish by applying functional programming to the problems they try to solve. Let's go through a few examples. The command pattern is very easy to simplify because at its core, it is just a workaround for languages that do not support functions as first-class citizen. It is based on simple inheritance. There is an abstract class command that has a pure virtual method execute. Then one derives some concrete command that implements it. These commands are then passed around and stored using base class pointers and so on. But today we do not need classes and inheritance for this. A command is just an std function with perhaps some impure behavior. And the state that can occur in concrete command is just whatever could be captured in a closure. So we now can create something equally powerful on the fly by writing a lambda function. And that's it. Let's have a look at a slightly more complex one, the abstract factory pattern. Okay, I guess we need to have a look at an implementation to get a better feel for it. Suppose we have different vehicle parts like wheels and motors. A wheel can be made for a train or for a car. A motor has the same two variants. Now we have your typical factory classes. One for car parts and one for train parts. Finally, we can use these functions polymorphically. Wow, this has become quite long. Can you guess how we can get rid of a lot of the complexity by replacing inheritance with functional programming? First, we create two enum classes defining the possibilities. Then, we write one single function capable of producing all kinds of vehicle parts. If it would get too long, we could still split it into smaller functions with grouping by vehicle type or by part type. Modern compilers will even issue a warning if you forget one enum case in your switch block, so you normally do not have to worry about this. Okay, but how can we now obtain the equivalent to a concrete factory in the original pattern to pass to our useFactory function? It is simply a matter of partial function application now. The type of our concrete factories now is this. In C++ syntax it looks as follows. So our useFactory function now looks like this. And we can use it as before. So in this example, simple partial function application renders all the inheritance stuff obsolete. Dependency injection in general, like used in the strategy pattern, can also often be expressed as partial function application. Another nice example is the decorator pattern. Say you have a function that does something like calculating the square of a value for the sake of simplicity. Now, every time you call this function, you want its input and output value to be logged to stdcout. But you do not want to do this manually every time, so you need a decorator for the function that adds this new logging capability to it. Its type would be this. And its usage would look as follows. The nice thing is that it can be used for every function having the same signature as square from now on. Here is an exercise for you. Implement decorate with logging so that it works like shown above.